All right, the answers to 3-3 practice. So the check your understanding, what is the ratio of the measures of the radius of a sphere to the measure of the radius of its great circle? Oh, it'll be 1 to 1. The great circle goes through the biggest part of the sphere, so it'll be 1 to 1. Two spheres intersect. I could not see this with this picture. Even with their explanation, I tried to draw it and I just couldn't see it. So, you know what I did? I Googled it and I found a decent picture. So, here is the center of one of the spheres. Here is the center of the other of the spheres. And so, draw the line where the center of the spheres is. And first of all, the center of that circle, the intersection of those two, basically what you have to just see is that this sphere at some point is going to kind of act like a plane, and the place where all of their points are touching each other will end up being this circle right here. And so that's what they're talking about over here on this when they say that it's the intersection of two spheres is a circle whose plane is perpendicular to the line joining the centers. So they're talking about the circle itself. This silver circle right here is perpendicular to that line where the centers are connected, and it also passes through the center of that circle. I don't think you have to worry about knowing that for the final exam, but they do want you exposed. Can this solid of rotation about the x-axis generate a three-dimensional figure as shown? And no, it's not symmetrical. No, the figure formed would have to be symmetrical about the x-axis, so it would not form an oblique cone. It would form a right cone. The axis of symmetry is the x-axis. So no, the only thing that we can generate is a right cone, not an oblique one. How do the areas of the cross sections of the sphere compare to each other? We saw that the farther you moved away from the center, the smaller the circles got. Identify the name of the greatest chord in a sphere. That's the diameter, just like a greatest chord in a circle is the diameter. What figure is formed by rotating this square? It would be a cylinder. And a square is just a rectangle, remember. Which of the following two-dimensional figures are rotated about the y-axis to form this 3D shape? Definitely B. B. C right here is close, but C would form like this lip, I guess, that would catch the drips. There would be like kind of like a bowl down here at the bottom. There would be these sides that would go up around. Okay, and it would be hollow in there, so like this would catch drips or something. This would form a bowl. We rotated that around the y-axis, we would get a hollowed out bowl, something like that. That's what we'd get all the way around. Oh, I don't know what that would give me. Some funny, silly design. Kiko designed a pendant for a necklace by rotating a square about a diagonal as shown. What is the width of the pendant at its widest point? That's just the diagonal of a square, right? Isn't that what they said? A square. So that's just the diagonal of a square. So if this is 2, this is 2, that's 2 root 2. That is the 45-45 special right triangle formula. X root 2. So that's it.